In this video, we're going to be looking at the difference between a distance and a displacement. So we're going to start on this map of downtown Ottawa. Distance is a scalar quantity, meaning that it is path dependent. So let's say we decided to tour Ottawa and we started at Parliament, here where this X is. And we walked along the streets, took a tour down Laurier towards Confederation Park, and it ended up at the National Arts Centre. Our distance would be every single step we took, so following that blue line. Our displacement is not path dependent, meaning displacement depends only on where we start and where we end up, and it's the shortest straight line between those 2 points. So our displacement would be this dotted red line. Our displacement is going to be shorter than our distance. And the displacement will have a net direction of southeast. And we could measure the displacement vector and then using this scale determine the actual distance between the Peace Tower and the National Arts Centre. Sometimes in a question, you'll be asked to add displacements up. In order to do this, we know that if we have our directions, so our little compass, north, south, east, and west, we're going to be dealing really in kind of these 4 directions. And for physics, north is considered to be a positive direction, as is east. South is negative and west is negative. So if I were to say that I moved 10 meters east, I could also write that as positive 10 meters. If I were to say that I moved 10 meters south, I could write that as negative 10 meters. And that's when comparing to north, or compared to the north for the south, or compared to the west for the east. So if I were to travel 10 meters north, we put north in square brackets, 10 meters north, then 50 meters east, then 10 meters south, then 20 meters west, I could figure out my displacement by adding these vectors together. So you could make a scale and draw them out, or we can group our north and south vectors together because they're in opposite directions, and we can group our east and west vectors together because they are in opposite directions. So north and south, we know that we traveled positive 10 meters, so that's our north, and negative 10 meters, that's our south. So when we add these 2 numbers together, we get 0. So that means that we didn't move north or south overall. We can do the same thing east and west. So we traveled positive 50 meters, that's the east direction, and negative 20 meters, that's the west direction. We add these 2 together and we get positive 30 meters. What that means is that our net displacement is going to be 30 meters east.